Good morning everyone. Welcome back to Doc GILMAC online tutorial. The topic I will be discussing for today's tutorial is all about the introduction of the basic sets operations or introducing sets operations. Okay? Now, before discussing the topic for today's tutorial, let's have first a simple warm-up drills. Okay? List all the possible elements of the universal set given the following sets. We have set A is equal to 1, 2, 3, set B is equal to 3, 4, 5. Alright, just combine all the elements of the A and B. Yes, very good. So we have set U is equal to 1, 2, 3, 4, and 5. Take note, both set A and set B have one common element, which is 3, and should only be written once. Okay. Number 2, we have B, C, D for set D, A, B, D, F for set E. What are the elements of U for the universal set? Yes, very good. We have A, B, C, D, F. Again, both set D and set E have two common elements, B and D. And take note, this should only be written once. Okay? Next, determine the cardinality of the following given sets. Let's have number 3. 1, 2, 4, 6, 9, 10 are the elements of set E. How many elements do you see here for set E? Yes, there are 6 elements. So, what is n of E? Yes, very good. It's equal to 6. Since there are only 6 elements for set E. Next, how about set F? 3, 5, 7, 9. N of F is equal to? Yes, equal to 4. Since there are only 4 elements for set F. How about G? A, D, F, G, H, I, J. What is N of G? Yes, N of G is equal to 7. Since there are only 7 elements for G. How about this? Number 6. Set H is equal to I, E, N, J, O, Y, M, A, T, H. How many elements of H do we have here? Yes, there are 10. So what is N of H? Yes, equal to 10. Okay? So take note of that. Now, let's have a simple recall on the contributions of John Venn. Okay? John Venn is a famous mathematician who introduced Venn diagram and extended Boole's mathematical logic, and is best known to mathematicians and logicians for his diagrammatic way of representing sets, typical subsets of the universal set U, and their unions and intersections. Okay? Now, let's have the basic operations on sets. The union of set A and set B, denoted by this symbol. Okay, this is read as A union B. Okay? Now, consider the Venn diagram here. Take note, the universal set is represented by the rectangle. And we have here set A represented by circle and another circle here, which is set B. Okay? As you can see here, this shaded part here are all the elements of the union of set A and set B. So from here, we have the following definition. Okay? When we talk about union of set A and set B, it refers to the combination of all the elements of set A and set B. Okay, so take note of that. Let's have an illustrative example. Given set A is equal to 1, 3, 5, 6, set B is 3, 6, 9. So if we are to determine the elements of A union B, we just combine all elements of A and B. And again, 3 and 6 here are common elements for A and B, N should only be written once. So just combine. So we have 1, 3, 5, 6, 9 are the elements of the union of A and B. Okay, so take note, 3 and 6 are common elements of set A and set B and should only be written once. So take note of that. Okay, next, number 2. The intersection of set A and set B denoted by this symbol. This is read as A intersection B. Again, consider the Venn diagram here. Okay, rectangle for the universal set and circles for both set A and set B. Now, how can we be able to determine the elements of intersection of set A and set B? So as you can see here, this shaded portion here are the elements of the intersection of set A and B. So from here, we have the definition of the intersection refers to the common elements of both set A and set B. So take note of that. Now let's have an illustrative example. Okay, set A is equal to 1, 3, 5, 6. Set B is equal to 3, 6, and 9. So as you can see here, there are two common elements here, and 3 and 6. That are 3 and 6 rather. Okay, so we have A intersection B is equal to 3 and 6. Okay, so again, take note, 3 and 6 are common elements of set A and set B. And also, that are the elements of the intersection of A and B. So take note of that. Okay, let's have the number 3 basic operation on sets. We have the complement of set A denoted by this symbol A prime or A raised to C. This is read as A complement or the complement of set A. Okay? Now consider the Venn diagram here again. So as you can see here, I have set A and set B. This shaded part here are all elements of the complement of A. So take note, these are all elements of the universal set. Inclusive are the elements of set B here. Okay. So from here we have the definition. It refers to the elements of the universal set that are not in A. So we should only list down all elements of the universal set that are not in set A. So let's have an illustrative example. So we have set U is 1 up to 10, then set A is 1, 3, 6, 8, 9. Actually, there are 5 elements for A here. So therefore, A complement are 2, 4, 5, 7, and 10. 1, 3, 6, 8, 9 are not included since they belong to set E. Okay? So again, take note, only elements of the universal set U will be listed that are not in set A. Okay? So take note of that. Now let's have the fourth basic operations on set. Okay? The difference of set A and set B denoted by this symbol, A minus B. Okay? Consider the Venn diagram again. For the universal set, represented by rectangle, and set A represented by circle, and also set B is represented by a circle. So as you can see here, if we are to determine the elements of the difference of set A and set B, this shaded part here are all the elements of the difference of A minus B, or the difference of set A and B rather. So from here, we have the definition. This refers to the elements that are in A but not in set B. So take note of that. A, let's have an example. Set A is 3, 5, 6, 7, 8, 9, 10, and set B are 3, 6, 8, 9. So as you can see here, these elements here of set B belongs to set A, 3, 6, 8, 9. So what we are to list down for A minus B are elements of A that are not in B. So we have 5, 7, and 10. So take note of that. 3, 6, 8, 9 are not included. Okay? So take note, only elements of set A will be listed that are not in set B. Okay? So take note of that. Now let's have a practice drill. So practice drills. Okay, perform as indicated. So given the universal set 1, 2, 10, set A is 1, 3, 5, 8, set B is 3, 6. So what are the elements of A union B? Yes, just combine all elements of A and B. So we have 1, 3, 5, 6, 8. 3 and 8 are common elements for A and B and should only be listed once. Number 2, A intersection B. So what are the elements of A intersection B here? Just list down all, yes, common elements. So there are 2 common elements and we have 3 and 8. Okay? So A intersection B is equal to 3 and 8. Next. Okay. A minus B and A complement. So let's just have the given here. So set U is 1 up to 10. Set A is 1, 3, 5, 8. Set B is 3, 6, 8. If we are to determine the A complement here, all we have to list down here are elements of the universal set that are not in A. So there are 4 elements for A here. So this should not be included in the complement of A. So we have the elements should be 2, 4, 6, 7, 9, 10. And take note, 1, 3, 5, 8 here is not included in the complement. Then for number 4, A minus B is equal to 1 and 5. Take note, 3 and 8 belongs to B. 3 and 8 are the common elements for both A and B. So all you have to list down here for A minus B are 1 and 5. 3 and 8 is not included. Okay? Let's say this. Given set U is equal to 1 up to 10, A is 1, 3, 4, 5, 8, and B is equal to 3, 6. So let's just represent this one using Venn diagram so that you can see how to use the Venn diagram rather. Okay, so we have here all the elements of the universal set here, set A and set B. So A union B here, so just combine all elements of A and B here. So we have 1, 3, 4, 5, 8, and 6. Okay, so as you can see here. Okay, the arrangement is not necessary. No? Okay, you can actually jumble this. Okay, in any particular order. Okay, how about A intersection B? As you can see here, there are 2 elements here. Common elements are 3 and 8. So you can actually see the common elements here. So A intersection B are 3 and 8. Okay? How about A complement? So as you can see, here are the elements of A, 1, 3, 4, 5, 8. So it's very easy to determine the complement of A. We have 2, 6, 7, 9, and 10. Do not include these 5 elements here of A. Okay? How about B complement? Again, it's very easy to determine. Do not include 3, 6, 8. So we have 1, 2, 4, 5, 7, 9, and 10. Yes? For B complement. How about A minus B? Again, it's very easy to determine here using the Venn diagram. Do not include 3 and 8 here. Okay? So there are actually 3 elements, 1, 4, and 5. A minus B are 1, 4, and 5. Again, there is a clerical error here. So, my apology. This should be equal to 1. So, the elements of A minus B are 1, 4, and 5. It's very clear here. 1, 4, and 5 in the Venn diagram. So, clerical error, this must be equal to 1. Okay, I repeat. Sorry for this. This must be equal to 1. Okay? Alright. Again, I would like to thank you for watching and stand by for my next tutorial. And may God bless us all.